Hello class. In this final series of lectures, which I'll be doing today, it should span 3 videos. We're going to be talking about 2 different ideas. So the first is the idea of rational choice theory and expected utility. This is going beyond logic, using the principles that we've learned so far and applying them to everyday decision making. So assuming that we accept a certain rationale for belief and utility, which we'll get to defining shortly, then we can predict what sorts of decisions we should be making. And this is called rational choice theory. We can calculate what are called expected utilities for different outcomes, for different actions. So when we ask, what should I do? All you need to know is the probability of a certain outcome occurring, and likewise, the expected utility of that outcome actually occurring. Then we compare the 2 different outcomes and probabilities, find out what to do, and move on with our decision making. So this is, at least the beginning part of this lecture will be a lecture on the logic of practical reasoning. Once we go through these basic ideas of the logic of practical reasoning, we'll move on to discuss proofs for God's existence using the principles of logic that we've already learned so far in the class. So 2 of our proofs for God's existence will be deductive proofs, and 1 of the proofs will be inductive. And then finally, we'll use the rational choice theory and expected utility through Pascal's wager to show why Pascal argued one ought to believe in God in the first place. Now, the purpose of this lecture isn't to convert you or to convince you of any sort of theological supposition. I just find proofs for God's existence to be totally fascinating. And I think it's super fun that the principles of logic that we've learned in this very introductory class can be utilized to represent arguments and to construct arguments for something as grandiose and large as, and perhaps even important as the existence of God. That you only need a 1,000 level reason and rational decision making course in order to prove God's existence. Now, I'm also going to go over objections to the views, because it wouldn't be a philosophy class if we didn't evaluate what's wrong with the arguments or what might be wrong with the arguments. So all that's coming up, but first things first is to talk about expected utility and rational choice theory. So I recognize that this is a PowerPoint and I'm recording it, and that it might be hard or perhaps even impossible to see the words. I don't know how the lecture will turn out when it uploads to YouTube. But if it is hard to see, what I've done is uploaded all of my slides that I'll be using for these videos to the Canvas page. So at this point, you could either skip out completely on the videos and just read the slides if you're confident with that, or alternatively, open up the slides and follow along with me as we go through them. So our first slide, expected utility. This is a definition, and it's important. It says that a predicted utility value for one of several outcomes calculated as the sum of the utility of every possible outcome multiplied by the probability of its occurrence. So this is a complex definition. We're going to break it down. We're going to have an equation for it. But basically, an expected utility is what I said at the beginning of this lecture. An expected utility is simply the measure of a probability of an occurrence against the utility of that, the goodness, the pleasure we might get out of it, the value of that occurrence weighed against one another. So a probability and a value weighed against one another and then compared with other weights of the same proportion, and thus we can determine by ranking these numerically occurrences, these weights, what to do. Generally speaking, the thing with the highest, the occurrence probability relation with the highest utility will be that which we decide to do. So in short, what this means is that what we're going to do is we're going to calculate the best outcome and we're going to choose it, simply put. So we should, as I mentioned again at the beginning of the lecture, note rational choice theory. Now this is a theory of economics and of logic generally. Also often appears in sociology and psychology when academics and researchers study like the mind or the practical decision making of regular people. Often what these researchers do is they assume a certain way of reasoning, which is the principle of instrumental rationality, which says that if a person has goal G and believes that doing A is the best way of achieving goal G, then the person will do A. So a rational choice then, under a principle of instrumental rationality, just says that if I think that the best way to get an ice cream cone is to drive through McDonald's, then I'll drive through McDonald's. However, if I think that I'm better off getting an ice cream cone from what's a good ice cream place around here? I don't know. I'm from Oklahoma. We go to Brahms for ice cream. So maybe I think it's better to go to Brahms for an ice cream cone rather than McDonald's because I'm in Oklahoma and there's more Brahms there than there are McDonald's. And so I'm more likely to find a Brahms than I am a McDonald's if I really want ice cream. So I decide to look for Brahms rather than look for McDonald's. This is just my instrumental choice playing out as a matter of rationality. So rational choice theory is a reconstruction of instrumental rationality that collapses goals and beliefs into preferences. So when we talk about wanting an ice cream cone, I'm talking about a preference that I prefer my ice cream cone to come from Brahms than I do from McDonald's. Second, we order the agent's preferences via assigning utilities. So maybe I get 2 utility or utils if we are using units to measure our utilities. I get 2 utils from a Brahms ice cream and I get 1 util from a McDonald's ice cream because I prefer Brahms, right? It's just much better ice cream. So based on these preferences for McDonald's or for Brahms, because the Brahms ice cream has 1 or even twice as many utils as McDonald's, then I will choose the Brahms ice cream. So this being said, finally we reformulate instrumental rationality as person S will choose the action that maximizes their utility. So whatever our preferences are, we rank them in such a way as to maximize the utility that we can get from different outcomes. So here's an example. Over here we have certain choices: chicken, salad, mystery meat, and chocolate. And over here we have ordinal utilities. This is just a way of saying how we're going to rank the utilities in question. So let's assume that our preferences are complete, that there's not going to be any sort of complicated details about like if-then conditionals on preferences. We can just say that I prefer this over this for the reasons of this amount of utility. And likewise for each pair of alternatives, the agent prefers one to the other or is indifferent. So if there's a tie, then the agent will be indifferent. It's a coin toss. Or there's a preference of 1 or 2. Now, philosophers argue about whether these things are psychologically sound, these assumptions are psychologically sound. For the purposes of this lecture and for understanding the theory generally, we're going to assume these base cases. So, second, we're going to assume that preferences are transitive. So if the agent prefers X to Y and Y to Z, then they also must prefer X to Z. So we're giving a certain mathematical structure to the way in which we're calculating and interpreting our preferences. So what we do is we fill in our chart. We say that chicken has 2 utility, salad has 1 utility, mystery meat has 1 utility, and chocolate has 0. So ordinal utilities only rank preferences. They don't measure the value of each preference to the agent, but we get our value from these assumptions. So the above table says that someone, for instance, Jane, prefers chicken because there's 2 utility for chicken to all other options for lunch. And because salad and mystery meat are tied, Jane is indifferent, and it would be okay to flip a coin to decide whether to choose between the mystery meat and the salad. And Jane definitely doesn't want chocolate. Maybe Jane is allergic to chocolate or something. Okay, so imagine that we're about to have lunch with Jane, and you know that she prefers chicken to salad, and both of these to chocolate. All are available at lunch. What do you predict that she'll choose? Well, given the ranking order of our preferences and the utilities that we get from them, and our rational choice theory, which says that Jane will do whatever she can to maximize her utility, well, we could infer that Jane will first choose chicken before she chooses salad, and both of those before she chooses chocolate at 0 utility. Okay. So again, you're in lunch line with Jane. You know she prefers chicken to salad, is indifferent between salad and mystery meat, and prefers all these to chocolate. What do you suppose that she'll choose? Well, again, we infer that Jane is going to choose chicken first, that salad equals mystery meat, that there's no difference. She's indifferent to her choice of one or the other of these. If chicken becomes unavailable, and she'll choose everything before she'll choose chocolate. Again, it's pretty straightforward. You just maximize utility as we assign values to those utilities in order to satisfy the psychology of rational choice theory. Okay, so we can calculate expected value or expected utility. We can do it in a couple of ways. We can use a chart or we can use an equation. We'll look at both of these options. So the rough and ready way of calculating expected utility is to multiply reward by percentage chance of gaining a reward, multiplying the utility by the probability, as I've been mentioning. So say we have a 50% chance of winning $200. $200 is our utility, and 50% is our probability. And we want to say maybe we have a choice. We can choose either bet 1 or bet 2, but we can't choose both. Where bet 1 will have an expected utility of 100 because it's going to be 0.5, right, times 200. The utility times the probability. Which bet should we take? Well, we have to compare the expected value or expected utility of our first bet with our second bet. So we're going to run the same calculation for the second bet, which is 1% of 7,000 is 70. So you might think, well, 7,000 is a lot of money, and it's only a 1% chance, but that's a lot of money. Maybe I should choose the second option for the opportunity of getting that huge amount of money. Whereas $200, I work a week or whatever at minimum wage, and I make $200, but 7,000 would take me a long time to make that much money. If you subscribe to rational choice theory and you want to maximize utility, then you're better off going to the 50% chance for $200 because the expected utility, where we multiply utility by probability, is higher. It's 100 in the first case as opposed to the 70 in the second case. Now, if we increase this number from 7,000 to 10,000, then we would also get 100, and we could be indifferent as to the choice. And at that point, now this is sort of a tangent, at that point, the difference between your maximizing utility isn't going to be enough to make a rational choice because, right, the utilities are the same. If this number is 10,000, 1% chance at $10,000. Rather, you're going to have to look to a different heuristic or assessment for deciding in cases of indifference. Now, this is not something that we're testing. It's just, I think, interesting that generally speaking, in cases of indifference, what we do is we look at the rewards and we look at the risk, the probabilities, and we determine a risk profile. So what am I willing to risk, and am I willing to put more on the line or less, and basically what we have to do in cases of indifference are look to deeper personal level values in order to determine what to do. And this seems to get away from a clear-cut choice of rational maximization of utility. But fortunately, we don't run into that problem here, and we won't in our examples going forward. That's just sort of like looking ahead to future classes, should you be interested in this stuff. Taking a game theory class, for instance, that's a problem you're going to have to deal with. But in this case, the rational choice is to go for the 50% chance at winning 200 because the expected utility is $30 or 30 units higher than our second bet. Okay, so what if we have a 25% chance of winning $200 and a 75% chance of winning $50? Well, what we're going to do is we're going to multiply 25 or 0.25 times 200, which is 50, and we're going to multiply 0.75 by 50, which is 37.5. So this gives us an expected utility of 87.5 because we add those two numbers together, right? When we're conjoining probabilities, we add them together. This is our restricted or general rule of conjunction, either one. And we find that our chances, if we construct our preferences, we should prefer the 50% chance of winning $200 first, the 25% chance of winning $200, and the 75% chance of winning $50, both over the 1% chance of winning $1,000. So we prefer B to A to C. The highest utility to the second highest utility to the third highest, or lowest in this case, utility. Okay, now we need to consider acts that have two consequences. I got a phone call, that's why there was a cut. I put my phone on airplane mode so it won't happen again. Okay, so we've only been considering acts with one outcome, right? With a 1% chance of winning $1,000, a 50% chance of winning $200. Now there's two outcomes here, but we're adding them together, so it's really just like one that we can join. Now consider if I have Act A, and Act A can end up in two different ways. So say for instance I'm playing soccer, and I kick the ball, but it's a risky kick because there's a defender present. If there's a defender present, then it's a low probability that I score the goal, but a high payoff. I get a goal for my team. However, there's also a high probability that consequence 2, I miss the kick, that I hit the goalposts and the ball bounces off, or that the defender or goalie is able to block the shot somehow. So there's one act, which is kicking the ball, and two different possible consequences. How do we calculate the utility of this? Well, what we do is we assign utilities to either consequences. So the utility of consequence 1 might be 100, and the utility of consequence 2 could be something like 0, it could be like 20, or it could even be negative 100, right? So maybe, for instance, this is the final minute of the game, and I need to be looking for a way to pass to my teammates in order that they might have a more clear shot and thus allow us to win or tie up the game and go into overtime. But if I kick the ball and I miss, then we lose the game. So there's a negative 100 utility, that we have negative utility. It's not just that I don't get anything good, but I'm actively harmed. And utilities can be positive and can be negative. Okay, and also what we need to do is we need to assign probabilities to our two different cases. So the probability of me scoring with the defender present is maybe 0.5, 1/2. It's actually pretty high. But the probability, okay, so let's say it differently. The probability of me scoring with a defender present is 0.1. There's a 10% chance that I score. But using our rule of negation, we know that 1 minus the probability of me scoring is 0.9. So the probability of me not scoring, right, the negation of the first probability of me missing is 0.9 or 90%. So there's a high chance that I miss, and a lot of negative utility. There's a lot of positive utility if I make it, but a very low chance or low probability that I do. So the expected value of act A, or the expected utility of A, equals the probability of consequence 1 of making the goal, times the utility of making it, plus the probability of missing times the utility of missing. It's pretty simple stuff. Which just says that the expected value of an act is the sum of the products of the probabilities and the utilities of the act. Okay, so let's use a different example. Say a lottery has 100 tickets, okay? And just one winning ticket with a prize of $90. What's the expected value of buying a ticket for $1? So the consequence is that we win in one case, and the other consequence, of course, is going to be that we lose, but let's look at the first consequence first. The utility of winning is $90, right? Because there's a $90 payoff for this bet. Okay, so likewise, there's a probability of 0.01 of winning this bet. That there's a 1 in 100 chance or a 1% shot, 0.01 probability. Consequence 2 is that my ticket is not drawn, I lose, and my negative utility is $1. I lose $1, right? And the probability of this happening is 0.99%. Again, we can say 1 minus 0.01, and this is consequence 1 is, or consequence 2 is the negated probability of consequence 1. So we take our equation here, probability of C1 and the utility of C1 plus the probability of C2 times the utility of C2. So we just plug in our numbers, 90 minus 1 times 0.01, 0.99 minus 1. Right? So the expected utility, or expected value of making this bet is negative 0.1, minus 10 cents. So were I to make this bet over and over and over, say in some sort of infinite loop, I would on average be losing 10 cents per bet. This is not a good bet. And this is how most bets are set up. This is why the casinos always win, is because the expected utilities of the games, of their slot machines and of gambling, of the roulette wheel, whatever it is, the expected utility is always in the favor of the casino. And the casino runs very much like the infinite iteration of tests, right? Because so many people are playing all the time. And because so many people play all the time, the casino, on average, wins out with the expected utility and thus makes buttloads of money. And every once in a while, somebody wins the $100. This increases confidence and makes people want to bet more. But that doesn't matter. The few one-offs, the wins here and there, aren't all Ocean's 11 loss and terror and tragedy for the casino. Really, it's this number, this very small margin of expected utility that makes the casino able to run its business and run it so well. Okay, so I think I'll pause the video there and start the next one before moving on to proving God's existence.